So number 22, we're going to use what property? The quotient property, because of the minus sign that we see right here, quotient property. So we're going to take both log base 4s, condense them to make it one single log base 4. So zooming in to the left side only, we have log base 4, they become one single log base 4. And because of the minus sign, we're not going to be multiplying these guys together. We're actually going to put this one over this one. Quotient property, make it a division situation, a fraction. So it's always the first one over the second one. Always the first one over the second one. So that will be x squared minus 4 over x plus 2. And of course, we still have the equal sign right here. Now, let's bring down the right side. That's just log base 4 of 1. That's interesting, because log base 4 of 1, that's actually equal to 0. 4 to what power gives you 1? That would be 0. But let's not change it to 0, because that might confuse some people, Jonathan. Sorry. So let's just leave it like that. We're going to get rid of log base 4 by raising both sides to become powers of base 4. That cancels, a 1 comes down, and we're going to have a new equation. Let me rewrite it. So from here, we're going to continue solving, and of course, I don't want this fraction with a variable x plus 2 on the bottom, so I'm going to multiply both sides of this equation by the binomial x plus 2. That way it'll cancel with that binomial x plus 2, but what I do to one side, I do to the other, so I have to multiply this side by x plus 2. And of course, when I distribute, it will simply become x plus 2 on the right side. So again, these guys cancel. I have x squared minus 4 on the left side equals x plus 2 on the right side. Now at this point, we recognize that we have a quadratic equation, and the best way to solve quadratic equations is to move everything to one side, set it equal to 0, then you could apply the quadratic formula, or you could try to factor, split, and solve. So I'm going to do 2 steps in one here, subtract x and subtract 2. I'm going to subtract x, which I'm not going to be able to do, but when I subtract 2, I will be able to do that with a negative 4. So my quadratic trinomial equation will be x squared minus x minus 6 equals 0. I hope I didn't lose anybody right there. So at this point, now I could factor by thinking what times what is negative 6, that if I add together is negative 1. And that'll be x minus 3 times x plus 2. Of course, if it's equal to 0, you could split them and solve. And if you did go x minus 3 equals 0, and if you did go x plus 2 equals 0, then you're going to get two answers. X equals positive 3, and also x equals negative 2. If you solve both of those, you get those two answers. However, even though we're done, we need to go back and make sure that we don't have negative values inside our logarithms, or 0, right? So if I go to 3 and plug it in here, I get a 5, that's cool. If I take 3, plug it in here, 9 minus 4, that's 5, that's cool. But down here, the negative 2, if I plug in negative 2 right here, negative 2 plus 2 is 0. Now that messes it up, because you can't have the log of 0. It just doesn't work. Even base 4, base anything. You can't have log base something of 0. It doesn't work. So the x minus 2 is what we call an extraneous solution. So the only answer is x equals 3. What would you like to see on this video? $26, okay. So, ladies and gentlemen, on number 26, we want to get rid of log base 16. The only way to get rid of log base 16 is if you only have log 1 of those log base 16s, not 2 of them, right? You only want 1 of them. Now, even if you moved 1 over to the other side, you'd still have the 1/2 that's being added or subtracted. That would mess it up. So the only way to actually get this going is to take both log base 16s and condense them to one single log base 16. Which property are we going to use to condense, knowing that there's a minus sign between the two logarithms? Quotient property. So I'm going to take both of these log base 16s and write them as one single log base 16. There it is. And then I'm going to take this value and put it over this value. Remember the quotient property. Quotient means divide, which is a fraction. So it's going to be this one over this one, or this one divided by this one, however you want to think of it. Anyways, let me write that as the fraction of log base 16. So we have that so far, log base 16 of that fraction, 9x plus 5 over x squared minus 1. And then we're going to bring down the equal sign, there's nothing else to do on the left side. On the right side, we have a 1/2. A 1/2. So let's bring down that 1/2. Okay, so now at this point, I only have 1 log base 16. Up here I had 2, now I only have 1. Now I could get rid of it. How do I get rid of it? By raising both sides of the equation to become exponents of base 16. So I want to put a big giant base 16 right there, and a big giant base 16 right there, and an equal sign between these big giant 16s. So what happens is that 16 to the log base 16 cancels out, and my new left side of the equation will be 9x plus 5 over x squared minus 1. And for my right side, I really do have 16 to the 1/2 power. What does that mean, 16 to the 1/2 power?
4.
That means the square root of 16, which is the nice, beautiful number 4. Okay, so at this point, I want to solve for x, but the problem is x is in the denominator of the fraction on the left side, so I don't want that x squared minus 1 down there, so I'm going to multiply both sides by that exact binomial x squared minus 1. That way, it truly does cancel out. But what I do to one side, I have to do to the other, multiply by x squared minus 1. Okay, so on the left side, I have 9x plus 5. And on the right side, I have 4x squared minus 4. And now that we have a quadratic equation, we could move everything to one side. So let's move everything to the right side here. Subtract 9x, there is nothing to subtract from. But you could also subtract 5 and subtract 5 from the negative 4. Okay? So our new equation, this cancels, it's going to say equals 0 on the left. On the right, you're going to have 4x squared minus 9x minus 9. Yay? Okay, so this is the quadratic trinomial equation that is equal to 0. It doesn't matter if you have equal to 0 over here on the left side, or you could just rewrite it with equal to 0 on the right side. It doesn't matter. At this point, you're either going to factor, split, and solve, or you could try to use the quadratic formula. Since we factored on the last one, and since this is more difficult to factor because of the a value 4, I want to go for the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And the way to apply that formula would be to replace all your variables with parentheses and then substitute your a, b, and c value. So there it is, setting it up. Let's actually plug in our a value of 4, your b value of negative 9, and your c value of negative 9. So the b value is negative 9, 4 times a, that's 4, times c, which is negative 9 also, and 2 times a, which is 4. So we have all those values plugged in, and now let's work on the radicand value, the value inside the root. So we really start out with negative 9 squared, that's positive 81. So we're going to have 81 plus something, because a negative times a positive times a negative is going to end up being positive. So I just wrote everything in blue up here. I still need to do 4 times 4 times 9 on a calculator. 4 times 4 times 9 is 144. So we have 144 right here. So the next step would be to add 81 and 144. Add 81 plus 144, you get 225. 225. And that's great because 225 is a perfect square number, I believe. So that's 15. So we're going to have 9 plus minus 15 divided by 8. And that actually provides us with two answers. The 9 plus 15 divided by 8 and 9 minus 15 divided by 8. So 9 plus 15 is 24 divided by 8. 9 minus 15 is negative 6 divided by 8. So 24 over 8, that's 3. And negative 6 over 8 reduces down to negative 3/4. Now those are our two answers. However, we need to double check and make sure that those values don't produce negative values inside the logarithms. So if I check 3, If I plug in a 3 right here, 9 times 3 is 36 plus 5. That's a positive number. It's all good. If I plug in a 3 here, 3 squared is 9, minus 1, it's 8. It's all good. So 3 works. However, when I try to plug in negative 3/4, if I plug in a negative 3/4 right here, when you plug in that negative fraction in here, you end up with a negative value all around, which makes that an extraneous solution. So the negative 3/4 does not work. So on your answer spot, you're only going to write the answer 3. You're not going to write negative 3/4. If you put negative 3/4, have to mark it wrong, you'll get half credit. So please make sure you only write the one that works. So number 26, that was a huge process. Any other one? 28? Sure, why not? Number 28 is interesting because it has an outside value of minus 1. So let's try to raise both sides to become powers of base 2. And this guy will cancel out. However, on the left side, it doesn't cancel out because of the minus 1. Well, not yet at least. So what we would have to do is split the base and write it as 2 to the log base 2 of 5y plus 2, and then times 2 to the negative 1 power. So this minus 1 out here, when I raise the whole thing to be the power of base 2, I need to split the base and write it as this times this. So on the first part, this will cancel. You'll end up with 5y plus 2 times 2 to the negative 1, which is really times half, if you think about it. And on the right side of the equation, you have 1 minus 2y. So on the left side, you really have the binomial 5y plus 2 times half. And if we distribute the 1/2 to both terms, it'll be 5/2 y plus 1 equals 1 minus 2y. So if the fraction confuses you, let's multiply everything by 2. When we multiply everything by 2, we end up with... Interesting. So if we subtract 2 and subtract 2, the 2's cancel. We're going to end up with 5y equals negative 4y, which means 9y equals nothing, which means y equals nothing. Okay. Now, we need to double check and make sure that we don't end up with 0 or negative numbers inside the logarithms, given that the answer is 0. So if I take 0, put it in right here, 5 times 0 is 0. 0 plus 2 is 2. So that's positive. So far, so good. Plug in 0 here. That'd be 0. 1 take away 0 is 1. So it looks like it works out. So check your answers, of course, on the answer sheet I gave you.